Radioactive decay is the spontaneous breakdown of an atom's nucleus, which then releases energy and matter from the nucleus. So, what does this actually mean? Well, let's rewind back to basic chemistry and look at what an atom is in the first place. So, an atom, in its basic sense, is comprised of a nucleus with other subatomic particles spinning around the outside of a nucleus. Now, an atom is comprised of three main subatomic particles. Those are protons, neutrons, and electrons. So, what does it actually look like? Here we have an atom's nucleus, and inside the nucleus, essentially like think about it as its brain, is where protons and neutrons reside, which are two of the biggest subatomic particles of the three. So inside the nucleus, let's just say for an example, inside this nucleus, there are two protons and two neutrons. Protons have charges of positive, and neutrons essentially have no charge. Spinning on the outside of this nucleus are the electrons. Now, this is a very illustrative diagram of an atom because as I'm drawing this, the electrons almost look like they're just as big as the protons and neutrons, which in reality, think of the nucleus as being the size of somewhere around a hot air balloon comprised of the protons and neutrons. And the electrons will essentially be the size of marbles spinning around this very giant hot air balloon. So the size of the electrons in comparison to the protons and neutrons are very, very small. Protons and neutrons, each proton essentially has a mass number of one, and each neutron essentially also has a mass number of one. Electrons are very, very small, and so they almost have a mass number of zero. So why are we talking about atoms? Well, atoms are the smallest unit of some kind of matter that forms a chemical element. And if you remember what elements are essentially different types of atoms that are denoted by their atomic number, which is essentially the number of protons that reside in the nucleus. Now, this particular atom has two protons, which means that any other atom that also contains exactly two protons will be of the same element, which is helium. And so, if you look at the periodic table of elements, which you can recall back to your basic chemistry, there are many different elements. And each one of the elements are defined in its basic sense by the number of protons that are residing in the nucleus. So, in this nucleus, I have two protons and two neutrons. Now, let's say that I add a third proton. This atom would not be helium anymore. It would be lithium, the element lithium. If we add a fourth proton, it wouldn't be lithium anymore. It would be beryllium. And if we add a fifth proton, it wouldn't be beryllium anymore. It would be boron, and so on and so forth. For the most part, each element has similar number of protons and neutrons, which means that especially for the elements that have lower amounts of protons and neutrons in their nucleus, it is almost a 1-to-1 ratio, which means that for lithium, in its nucleus, there are essentially three protons and three neutrons in its nucleus. The same thing for beryllium, four protons and four neutrons. For boron, five protons and five neutrons. For carbon, it would be six neutrons and six protons. So we define an element or an atom. An element is defined by the number of protons in its nucleus. But what happens, and let's say that this nucleus has three protons, so it's still lithium, but let's say that it has four neutrons, which can happen in nature. This nucleus would now be considered unstable because There are more neutrons than protons. How I can think about it is that in the nucleus, in order for it to be stable, each proton essentially wants to have a neutron that it can essentially pair up with. So in this case, we have 3 protons and 3 neutrons that evenly pair with one another, but we have 1 neutron that essentially just in there by itself. It has no pair, which means that it is unhappy. Its nucleus is now unstable. An unstable atom is going to want to decay, essentially change by emitting some type of matter and energy so that its nucleus can become stable. A nucleus becomes stable when the number of protons and neutrons are essentially the same. So when we get that ratio closer to 1, that atom will then become stable. For all the elements in the periodic tables, there are an abundance of isotopes. So there are many isotopes, essentially differences in the nucleus for each element. So what does this actually look like in the atom's nucleus during radioactive decay? The nucleus of the atom in its unstable form wants to become stable. So what happens? It has to sometimes kick out particles or change particles from one to the other. We're only going to really highlight 2 of the decay potentials right now, which is alpha and beta decay. The reason being is that gamma decay doesn't really emit a particle, like a matter particle. Instead, it emits energy in the form of light, also known as a photon. So let's take a look at the first type of decay, and that is alpha decay, that emits an alpha particle as a result of radioactive decay in the first place. So what happens is alpha decay occurs in elements that have an atomic number of greater than 82, which means it has 82 or more protons in its nucleus. So any elements that you see on the elemental table with 82 or greater as their atomic number are more likely going to undergo alpha decay because that nucleus is so unstable and so heavy. So let's take a look at this example. Here we have a nucleus that has 88 protons and 134 neutrons. So what do you think is going to happen here? It is extremely unstable. There are many neutrons that essentially don't have a proton pair, which means that ratio is far from 1. In alpha decay, it emits an alpha particle, which contains 2 protons and 2 neutrons. So what will happen is that as this nucleus decays, it's going to kick out an alpha particle that looks just like a helium atom. So in turn, it's kicking out 2 protons from its nucleus and 2 neutrons from its nucleus. So now this new particle would have 86 protons and 132 neutrons. It is important to note that in alpha decay, you are not changing any of the particles. You're not changing a proton to a neutron or a neutron to a proton. You are simply having the movement of these subatomic particles from the interior of the nucleus to the exterior. So now that brings us to our last style of radioactive decay, which is beta decay. Now there are 2 types of beta decay. There is beta minus decay and beta plus decay. So in beta minus decay, the mass number stays the same, which means that the mass number, as we know, is the combination of the protons and the neutrons, which means that you're not kicking out any particles to change the actual interior of the nucleus. Therefore, you are changing a subatomic particle from one to the other. So in the case of beta minus nucleus, a neutron changes into a proton. So if you look in this nucleus right here, there are 6 protons in the nucleus and 8 neutrons in the nucleus. So there are 2 more neutrons than protons, which means that this nucleus is pretty unstable. So what will happen is that one of these neutrons will change into a proton. As this neutron changes into a proton, it's kicking out a beta particle as well as an electron. So now, because that this atom has undergone beta minus decay, the nucleus will now have 7 protons and 7 neutrons. Now let's take a look at this. Previously, before this atom underwent beta minus decay, it had 6 protons. But now this nucleus has 7 protons. So because this original nucleus had 6 protons, aka carbon, but now it has 7 protons, it's not carbon anymore. It is now nitrogen. So in beta minus decay, even though you're not necessarily changing the mass number, you are changing the subatomic particles within the nucleus from a neutron into a proton, which means that this atom was once carbon, is now nitrogen. The last style of beta decay is beta plus decay. And this is a little bit different than beta minus decay, because in beta minus decay, you're changing a neutron into a proton and you kick out an electron. With beta plus decay, you're changing a proton into a neutron and kicking out a positron. So let's take a look at this last example. Here we have an atom that in the nucleus contains 6 protons and 4 neutrons. So 6 protons, it is carbon. But there are 4 neutrons in the nucleus, which means that this atom is unstable. So what happens here? One of these protons is going to want to change into a neutron so that this nucleus, this atom, can become stable. So what happens during beta plus decay is that one of these protons will change into a neutron. And in turn, it kicks out a beta particle. And it also kicks out a positron, essentially an anti-electron. So now, because one of these protons has changed into a neutron, the center of this nucleus now has 5 protons and 5 neutrons, which means that this atom is no longer a carbon isotope. It is now a stable atom of boron.